Hi friends, welcome back to my channel. So in this tutorial we are going to solve this integral. So I'm going to use the Laplace transform to solve this integral. So I'm going to start off by really doing a u-sub. We can let t to be equal to a negative ln of x. So we can do the change in limits. In this case we have that negative t to be equal to the natural logarithm of x, that is this one, and x can really be expressed in terms of t as e to the negative t, right? What about the change in limits? When x is equals to 0, t is going to be the negative ln of 0, which is going to be the negative of the negative infinity, which is the positive infinity. When x is equals to 1, that is t to be equal to the negative ln of 1, that is going to be 0. And here we can find an expression for dx. Dx is going to be negative e to the negative t dt. So we have an expression for dx which we can plug into our integral. So we can really now at this moment take our integral from the x world into the t world. So that's going to be the integral from infinity to 0 of the sine squared of so ln of x is going to be negative t, so that is going to be negative 2t, like this. Okay, times dx, and dx is going to be negative e to the negative t dt, and that is going to be the negative all the way in front, the integral from 0 to infinity of e to the negative t sine squared of negative 2t dt, right? So this one we can switch our limits, and that will nullify the negative, and that is going to be e to the negative t. Sine square of negative 2t is sine square of positive 2t dt. And we can compare this one to the Laplace transform. If you have the Laplace of a function f of t, that is really going to be the integral from 0 to infinity of e to the negative s of t times the function f of t dt. This is the Laplace transform. So our integral is just the Laplace transform of the sine square of 2t. So this integral is really the Laplace transform of the function sine squared 2t, and we are evaluating that at s is equals to 1, because here s is equals to 1 because it's just negative 1 times t, so s here is equals to 1. So we have the Laplace of that, so the Laplace of the sine squared 2t at s is equals to 1. So this one can also be written as the Laplace. So from trigonometry, this one is the same as 1/2 1 minus cos of 4t, like this. Evaluated at s is equals to 1. This is how sine squared 2t can also be expressed. And this one is now the Laplace of 1/2 minus 1/2 the cosine of 4t, evaluated at s is equals to 1. So this is the Laplace of 1/2 at s is equals to 1 minus the Laplace 1/2 the Laplace of cosine of 4t, evaluated at s is equals to 1. So the Laplace of 1/2 is really, let's say 1/2 and then 1 over s. This is just the Laplace of 1 over s, evaluated at s is equals to 1 minus 1/2. The Laplace of cosine of 4t is going to be s all over s squared plus 4 squared, which is 16, and then evaluated at s is equals to 1. So this one is going to be 1/2 at s is equals to 1, that is 1 over 1 minus 1/2 1 all over 1 squared plus 16. So nice and sweet. This is 1/2 minus 1/2 of 1 all over 17, right? And how can we simplify this one? This one is 1/2 minus 1 over 34, right? So this one is really going to be, the LCM is going to be 34, and that is going to be 17 here minus 1, right? And that is going to be 16 over 34, and that is going to be 8 over 17. So this is how an integral can be simplified. So therefore, the integral from 0 to 1 of sine squared of 2 ln of x dx, this one can be simplified, or the answer to this is 8 all over 17. That is by courtesy of Laplace transform. We can also solve this using the Euler identity, but I think this one is far simpler. So you can also solve this using IBP, that is integration by parts. But I have a video using the Euler identity. So this one is by courtesy of the Laplace transform. And our answer is 8 over 17. So if you really find this video helpful, make sure to smash the subscribe button for more engaging content from Calculus Diaries. I thank you so much for watching this video, and I will see you in the next one. Bye bye.